Hi, my name is Fermin Perez. I'm a product application specialist with Rivulis Irrigation, and in partnership with EcoDrip, today's objective is to talk about the correct design of a drip system, how to use the right equipment, and the proper maintenance of that equipment. And our agenda is to introduce you to Rivulis and introduce you to EcoDrip, and to talk about the advantages and challenges with SDI, and talk about some of the keys to success with SDI, irrigation design, system installation, proper system installation and management, and maintenance. Rivulis, I guess, is in the dictionary, is a small stream or a river in Latin. And we named our company Rivulis as we provide smart irrigation in its purest natural form, a river of life, giving hydration and bringing sustenance to crops. Rivulis is a global micro irrigation dealer with more than 50 years of expertise in the micro irrigation industry, and they were born and raised in 3 continents with one objective: is to go beyond to solve the irrigation challenge in global agriculture. We're committed to providing the right solution with the broadest, most comprehensive micro irrigation portfolio, plus a complete turnkey projects for any challenge, from individual growers to large corporate plantations. Rivulis is headquartered in Israel and is operating across the globe. There's over 50 years of industry expertise and experience, 15 manufacturing and distribution facilities with 3 R&D and 4 design centers. There's several thousand employees globally. There's an extensive line of irrigation solutions. We serve the agriculture, horticulture, landscape, and mining industries, committed to long-term win-win partnerships, and we're the #2 drip irrigation player worldwide, I guess. As you can see, our global footprint, see all manufacturing and design centers. Built on passion with a rich history and clear vision going forward. It started when John Deere, the company, acquired Plastro, T-Tape, T-Systems, and Roberts Irrigation, and made it into the John Deere Water Company. And the John Deere then spun it off to Rivulis, and Rivulis then acquired or got in partnership with the Indian company Jaya. Then Manna came into play in 2016, which is a precision agriculture, satellite crop monitoring. And then in 2017, Rivulis merged with EcoDrip, and in 2019, Polyplast in Russia came into play. We offer the widest range of drip lines and drip tapes, manufacturing the world's most trusted drip products, including T-Tape, D900/EcoDrip Compact, the D1500/EcoDrip Classic, the D5000 PC, which probably has the best emitter in the industry, the best pressure compensating emitter in the industry. There's the R5000 PC, the Super TIF PC emitters, and the road drip line or drip tape, and more. Our partner, EcoDrip, was established in 1984. It's a full-service subsurface drip company. They specialize in design, installation, and support of SDI systems. EcoDrip has 90 employees with specialists in design, service, fertigation, and moisture management. They believe in not only providing producers with a superior irrigation system, but also guiding them as they learn to utilize their new system. They have 6 warehouses in Texas, and 1 in Nebraska, and 1 in Oklahoma, plus a dedicated service center in Lubbock, Texas. They have installed over 200,000 acres of subsurface drip. They have 19 SDI consultants covering the majority of the central United States. So what are the benefits and keys to success in subsurface drip irrigation? What is success to you, the grower? What we say is success is farming is the ability to grow a quality crop with above average yields in the most efficient and effective way. A typical Mid-America SDI system is where the tape is buried about 10 to 16 inches deep. An SDI system can be anything from 4 inches to 16 inches in depth. But we're going to be talking about concentrating on the SDI, a deep burial SDI. Typically, the soil surface remains dry. You don't bring the water above the surface. It kind of eliminates the growth of weeds. It is installed permanently. And we say that in quotes because it can go up to 10 years or more. It depends on what you want to do. Some will go 10 years and then they'll replace it. It's in the thicker materials, maybe 13 to 15 mil. The mains and your submains are permanently buried. Different crops can be grown on the same beds in a rotation, such as if you grow corn, you can rotate it with soybeans. And some of the sample crops that are used in SDI are corn, cotton, beans, alfalfa, wheat, etc. So what are some of the advantages? Some of the following advantages apply to both shallow and deep burial SDI. However, the focus of this presentation is deep burial due to the unique requirements when designing a multi-year drip irrigation system. So some of the advantages are that the farm equipment can enter anytime, even while irrigation is in progress, because the furrows remain dry. Doesn't get muddy. Sprinklers, the whole field is wet. So in this case, the surface is dry. The equipment can come in anytime. There's less evaporation because the soil surface remains dry. There's less disease pressure due to dry soil surface, and even the crop canopy remains dry because it's not a sprinkler. It's all coming from the root zone. Drip laterals are less susceptible to damage by equipment or workers. There's nobody walking on the tape that's on the surface, especially if there's sticks and rocks on the surface and equipment and workers are walking on it. You're going to get punctures and cuts. The water application is not affected by the wind as it is with sprinklers. As you guys know, any wind that comes through, you get the water on the road. There's more controlled depth of application because you can run in as long or as little as you want, and you can control the depth of that water. And you can bring it up almost to the surface without getting it all the way to the surface. The upper portion of the root zone, just below the surface, can be kept moist. And this is where the plant mostly takes the nutrients in the upper portion. And so nutrients such as phosphorus and ammonium, they're concentrated near the soil surface, and you want to be able to get the water to that point, but not all the way up to the surface. And there's chemical-laden water is not accessible to animals for drinking. As you know, with sprinklers, you leave puddles, and if there's chemicals in the water, some probably protective animal is going to come drink the water and die. So that's one of the advantages. There's less soil compaction. The surface is not wet, and the tractors are, and that also keeps the most of the equipment out of the field. You don't need to bring the equipment as often into the field when you're using SDI. But it's less soil compaction, which is a great thing. It keeps the soil pretty fluffy. No deep ripping required because the soil is soft. Better control over harvest time and market timing. You can water all the way up to the end if you want, to the last day, and you can be harvesting because the furrows are not wet. The equipment can come in, and you can still be watering at that point. Water can be applied as often as needed to maintain optimum soil moisture for improved growth. Fertilizers and crop protection chemicals can be applied when needed without interrupting normal field practices. As I said, it's all underground. You can be applying fertilizer, you can be watering, and equipment can still be coming in and out. The fertilizer is spoon-fed only in the amounts needed right at the root zone. You're not putting the chemicals into the furrow. It's not going out with the tailwater. It's all being spoon-fed right at the root zone. Higher frequency irrigation is possible. So if you can pulse, you can run a few minutes or whatever, an hour, and then you can shut down for a while, and then you can run it again. And that way pulse the water to get it to move out. High water use efficiency is possible with good management. And of course, it has to have a good design with a good distribution uniformity. There's no tailwater to eliminate. And the flush water coming out of the hoses can be controlled. You can have a manifold at the end with one valve that shoots the water off the side of the field. Systems can be installed on almost any size and shape of parcel. So what are the potential savings and or improved efficiency? Well, with water, often less water is used. However, this is not always the case. It is almost always applied more uniformly than with flood or sprinkler. And the response is more crop per drop. What you do here is that the crop needs a certain amount of water. So you can't give it less water than what it needs. And even if you're really efficient with your sprinklers or your flood, you're still getting water in the furrows. You're still getting water where it shouldn't be. So in the end, the efficiency is a whole lot better with drip because you only put it right where it's needed. Energy. In most cases, the irrigation efficiency is improved and energy efficiency may be improved overall. The pumps are running more efficiently. When we talk about energy, you don't use your equipment, or your tractors don't have to go into the field as often when you're using drip irrigation because you do a lot of it through the drip. That energy there, diesel and tractor maintenance, and all that is getting better, getting more efficient. Fertilizer. Many times less fertilizer is used, and almost always is used more efficiently. So better crop response to the same amount applied. Growers have cited a reduction of up to 50 to 80% in nitrogen fertilizer usage. And so the main point of this is the total input of the above items is not always reduced. However, the return on the same input is often increased and sometimes dramatically increased. Some of the other grower observations are fewer workers injured because the soil's not muddy, therefore workers do not slip and or strain their backs as easily. Less labor cost. There is less labor cost, but there's more management time. quicker maturing crops, possibly earlier harvest, which may mean higher prices. What are the challenges? First, your distribution uniformity can degrade quickly with time. If you don't filter it well, you filter your water correctly, if you don't flush your laterals, your drip tape or hoses, and if you inject the wrong type of chemicals that interact with each other and cause a coagulant that's going to plug the emitters. The berry tape is susceptible to rodent and insect damage, so that has to be treated maybe in the off season. Water must be available on a frequent and dependable basis. You can't wait for the ditch rider to bring you water from the canal when you're gonna run your system. You need to have it accessible, have a pump, a well where you can get your water when you need it. Salt buildup is possible on the soil surface, and you need to be careful with that. You may want to run your system several hours to push those salts out of the way. You need an excellent design. You need an excellent design, a management scheduling, or a management and schedule, and a maintenance that is going to keep that system running the way it should for the whole season. Or you may have failure, catastrophic failure in some cases. Keys to success. A professional designer designs a system that takes into account several specific field characteristics in order to maximize crop ROI. You know, a tape or drip line selection is critical. A filter, of course, is very important. Pressure control devices, valves that control the pressure to keep the pressure at what it should be in the 8 to 12 PSI range. Flush outs and or flush manifolds, air and vacuum relief. Also, you need to take into account the topography of the field. Is it high, is slope, very, slopey undulating fields? What is the size? What is the length of the field? And design, it has to be a perfect design. And what kind of drip line do you pick? If it's undulating fields, very sloped, or very, very long runs, you may look at a PC type of drip line. If it's a standard field, fairly flat, moderate lengths of run, you have products that are not pressure compensating that we offer, but they're excellent for plugging. And the tape wall thickness chosen depends on your soil texture. Does it have rocks or sticks from a previous crop? And also the depth of your burial, how deep are you going to bury it? And that's your thickness, a deeper, maybe a little bit heavier, thicker wall. Then how many times are you going to use it? Are you going to do it 1 year, pick it up, throw it away? Well, you can go with a thinner material. If you're going to try to keep it in there for 10 years, I would suggest you go with one of the thicker products. Practicality, affordability, and what can you afford? What are you willing to spend on the product? And special requirements. Now, if it's high insect pressure, you don't want a real thin product, especially if it's shallow buried, and the system's going to sit there dry for several weeks before you put water in it. That's when some of the insect like to really attack the hose. Tape emitter flow rate and spacing depends on crop requirements. You know, if it's a crop that's closely spaced, you don't want an 18-inch spacing on your emitters. You want to get it closer than that. You want an 8 or 6 inch. And also, how much water does it need? Are you going to be able to have, using the tape that you picked, are you going to be able to run this system and go through all your blocks in the allotted time and be back to the first block when it needs the water? Or are you going to run out of time because your flow is too low on the tape? You need to take that into account. The soil type. If it's a very sandy soil, you don't want your emitter spaced out really far. If it's a heavy clay soil, you don't want it to be too close. You want to space them out a little bit. And are you going to germinate with this product? You want to make sure that you have a continuous wetted pattern where the seed is. You don't want it to be spaced out too far and you miss some of the seed in between. Filtration. It's critical because if you're coming off a well that's very sandy, or a canal, let's say a river, and it's just overwhelmingly sandy, we would suggest a sand separator. What this does, it actually takes care of inorganic particles that are heavier than the water, and it spins them and throws them down to the bottom tank where you can get rid of them. And this is before your main filter. You want to put it before your main filter because sand overwhelms any filter, even the sand media filters. The sand starts accumulating in the filter. You can't really flush it out because it's as heavy as the sand that's in the filter. So when you want to do this and then follow it up with a sand media or an automatic screen filter. Pressure control devices. Most of the tapes are made to run between 6 and, let's say, not even 15, maybe 12 PSI. You got to have a way to control the pressure going into the tape. If you're coming in at 40, you got to get that one down to 10 or 12. So a good pressure regulating valve comes into play. You have to have air vents. Air and vacuum relief are very important to a system, a drip system. When you look at air vents, air and vacuum relief, there's 3 different types. There's the vacuum breaker, or they call them vacuum breakers, but it's air and vacuum relief valve, which they're kinetic, referred to as kinetic, and they release large quantities of air to prevent air entrapment, and they emit large quantities of air to prevent vacuums. And these are excellent. But what they don't do, once the system starts up and it gets rid of the air, then it seals and no more air comes out during the time that the system's running. Until you shut the system down, then the ball drops and it lets a lot of air in to prevent vacuum. But if you go to a continuous air release valve, this continuously releases air during the time that the system is running, small amounts of air, because air accumulates. Even if you get rid of all the air that's in the pipeline, during the time that the system's running, air accumulates because air is like 2%, or I'm sorry, water is about 2% air. And so the air bubbles are going to keep accumulating at the high points. So you want these valves at the high points to release small amounts of air as the system runs. Or if you want to step up and then, pay a little more, you end up with a combination air vacuum continuous valve, which will, what it does, it releases a lot of air on startup. It releases air during the time the system's running, releases small amounts of air, and it actually will allow large quantities of air to come in when you shut the system down to prevent vacuum. So it's a insurance pretty much for your system. Thin wall drip lines, such as the Rivulis D900, it has a compact dripper. It's a great plug resistance, and it's a tiny little dripper, which works great. There's pressure compensating lines such as the D5000 PC. Excellent uniformity, probably the best emitter in the industry for regulating and for plug resistance, the Rivulis D5000 PC. We're going to talk about emission uniformity and distribution uniformity, as well as efficiency. What's the difference between, because some people call it distribution uniformity, some say it's efficiency, some say it's emission uniformity, and this is what I see. An irrigation system, the EU refers to the uniformity of the water distribution along a single drip lateral. How uniform is it between the first emitter and the last emitter along a drip line? And we always shoot for 90 to 95% from the beginning to the end of this drip line. And of course, this is going to depend on the topography. Is it sloping, or the emitter exponent, and the plugging resistance. How quickly is this emitter going to plug? So that's the emission uniformity. Then there's the distribution uniformity, and the way I see it, it refers to the uniformity of the water distribution throughout a complete block. How different is the flow from the first lateral to the last lateral? And of course, this is going to depend on topography, the sub-main size, and the plug resistance of the emitters. What happens here is that you can have perfect uniformity here. If we go to the efficiency slide, if you have a perfect uniformity from this, in this lateral here, we'll go back to the distribution, perfect uniformity, and you can have perfect emission uniformity in this lateral too, from here to here. But if the elevation difference between this one and this one is significant, and you don't have a way to control that pressure going down the hill, then even though this is perfect from here to here, this is perfect from here to here, the difference between this one and this one is going to be significant, because this is going to have a lot more water than this one. So what's going to happen is your system's not going to be very efficient, because you're going to have a lot less water up here than here. So in order to give this one the right amount, you're going to be overwatering this one here and wasting water. So that's the difference between emission uniformity, which is along one lateral, distribution uniformity, which is across the field, and your efficiency. How well are you utilizing that water? What are the keys to success in the system installation, management, maintenance? So important things to check. Install the tape with the emitters facing up. Very important. What happens every time you shut your system down, everything that's in the water, any contaminant or any silt or sand, will settle to the bottom every time you shut your system down. Now, if your tape is installed with your emitters facing down, what's going to happen is the contaminants are going to settle to the bottom where the emitter is, where the emitter inlet is, and it's going to start plugging the inlets to that emitter. And as you do it, next irrigation and next irrigation, it's going to accumulate to the point where it's going to plug that emitter. So it's very important to install the tape with the emitters facing up. Now, check the installation equipment. For sharp edges, burrs, it doesn't really matter how thick the tape is. If there's a burr or a very sharp edge that's going to be rubbing against the tape as it goes into the ground, it may not look cut at that point, but once you run it for a while and it inflates and deflates, that cut is going to open and you're going to have a mess out there. So it's very important for you to check the installation equipment, run maybe some sandpaper through there. It used to, many years ago, what they would do is put a penny hose through there and run it through, and some of the burrs would catch on it. And it was an excellent way to know if there was something in there that was going to be damaging the tape. You should place the spool of the tape directly above the injection shank to minimize the tape twisting. I've seen systems where they install it way to the right and it's having to come across and it gets all twisted to go into the shank. Or they put it way in the back and has to come to the front and go over pulleys and do all this and then go into the shank. It's so much easier to put it just right directly above. Use a GPS guided tractor. That way, every year, the tape's going to be exactly in the same spot. Or even if it stays in there for several years, you take it out and you're going to put a new one in there, it's going to go in exactly the same spot. Very important to run the system within 30 days of tape installation to prevent compaction of the tape, especially on the heavier soils. What happens is you install the tape and then you start installing your other equipment, do your filters and all that, and it rains. It rains, you get quite a bit of rain, and you don't do much for a while. That ground settles, and it's a heavy ground, and it flattens the tape, and it sits there and dries. Then when you start the system up, it's going to take you a long time to get the tape to open up. You may have to pulse it. You may have to run it for 24 hours a day for a while to get it doing it. So if you run it, especially if it's going to be some rain, run the system, get the water to it right away, make it inflate. It actually creates a little tunnel in there. And it's going to help you in the long run. Do not try to inject tape in a diagonal direction relative to the way the fuel was worked. It may not seem like a big deal, but it's always good because the water follows a certain path, and it's kind of erratic when it's going to rip at an angle, and you try to set the tape in another direction, and you can kind of see it looks like a uniformity. It's not that great, even though the tape's fine. And be careful of cutting the tape off the tape spool. I'm sorry, cutting the wrapper off the tape spool. I've seen where they do use box cutters to cut across the top of the roll and to pull that clear plastic off, and they cut into the tape in a bunch of areas. Another thing is, so what they do is they'll take the roll, they're on the back of a big truck with a wooden bed that's not in real good condition, and they'll drop the roll on it and they roll it to the edge so the guy can pick it up and take it to the tractor. And there's rocks and there's nails and there's pieces of wood sticking up, and that will puncture holes in the tape, and no matter how thick it is. Chemigation, fertigation. You can run your fertilizer through there, and you need to apply it when it is needed, even if it's raining. There's a certain time where you have to apply your fertilizer, and what's neat about SDI is that you can just start your system up, and it's applying the fertilizer right where it's needed in the root zone, because it's what it's doing is spoon feeding the micronutrients in there. You need to run chemicals sometimes to prevent the plugging of the emitters. Now your schedule is very important. Your goal is to maximize ROI, maximize outputs and minimize inputs. So how often and how long should you run? Your designer can help you with that. Well, of course, it all depends on the crop. If you hear of somebody saying, "Oh, I run mine 5 hours every week or every 4 or 5 days," well, first of all, what's the size of the plant? Now, what stage is it in? You can't just copy that. Is it at the peak season in July, or is it? So there's a lot that goes into it where your designer can come in and help you out. And of course, it all depends on the soil type, the growth stage of the crop, and the weather. Flush your system. Very, very important. Very important. You flush your filters when you first install them. You flush them several times. If there's sand filters, you put new sand in there, you flush them. Get rid of all the fines that are in there. Get rid of that. You flush your main lines when you put them in. You flush your laterals, your tape laterals. Open the ends and just let it run, because as everyone knows, when you're doing installation, there's always something getting into the pipelines. There's always mud. It rains while you're doing it. Something, and mud goes in there. All that, you need to open the ends and flush it all out. How often, when you start running your system, how often are you going to run? Are you going to flush it? You can run it for a couple of weeks. Go to the end, open the ends. Water looks clean. Take maybe a fine mesh like from a filter, put it on, see what it catches. If it catches a whole bunch of stuff, then you know you have to flush it at least every 2 weeks. If it's very clean, you wait a while, go open the ends again, do the same test. If you start seeing a little bit of contaminants in there accumulating, then you know you have to run it at least like once a month. Flush it. Also, maintain your filters during the season. Flush them, open them up, look, see what's in there, and flush them again. Make sure your gauges are working correctly from the inlet to the outlet, because if your gauge is broken and you don't know that, you think your system's running perfectly, and it may not be. So check your gauges. Monitor your pressures, your flows. A water meter is a great tool, because if you have a break in the line that's buried and you don't know it, it can be running for a while, but your meter will tell you that. Your meter starts spinning faster. You can see the numbers going really fast, and you're going, "Oh, there's something going on out there somewhere." So that's when you go look and see. And also going back to cleaning or flushing your lines, is during the season, sometimes somebody will run over a valve and break a pipe, and mud goes into the hole and it goes into the main line or the sub-main. Open the ends of the sub-mains after you connect it back up. Open the ends of the tape, flush it, and flush it until the water comes out clean. Get rid of all that. Winterization. Clean and flush your system thoroughly. Always flush your system before the winter. If there's chemical scale building up in your tape, you can treat it with acid. When there's no crop out there, you can pour the acid in there. It's not going to affect the polyethylene. If there's algae buildup, treat it with chlorine. You can superchlorinate. You flush your system thoroughly after treatments. Make sure of that. In some cases, you can use Treflan for root intrusion. All the above ground components, your filters, your pipelines that are above ground, valves, they must be drained before the winter, especially in areas where it can freeze. PVC pipelines above the frost line must be blown out and or drained. Just open it and just drain them somehow, or if some way you can get air into them to blow all the water out, please do that. And you can treat for gophers in the off season. Measurement of success is a correct design, the right equipment, and a proper maintenance plan. That's it for today. Thank you for joining us. And you can please call Rivulis or call EcoDrip anytime.